tangent is...
That would be the
within
linear
circle.
acceleration, right?
No, linear acceleration is here. It's a combination of tangent and radius acceleration.
That's a times r.
The tangent is a times r.
Right. That's what we have. That's what I just wanted to know. That's what you're looking for here.
Yeah,
That's
I
what you
mean-
did here.
but that's not the tangent acceleration. That's not the linear acceleration. The linear acceleration will be the tangent square the square root. So you have these, you have this. The combination is a linear. You can maybe check with your professor again, but the answer should be correct. Because here, what you get is 2 times 0.1, right? It's 0.2. That's what we get. It's 0.2 meter per second square. So if you think that is the linear, the answer should be E. But actually, this question, the answer is A. Right? The answer is A for this question. It's not 0.2.
Because it's 2 times 0.1.
Yeah. That's why I'm saying the linear should be the combination of these two, because the answer is not tangent, the acceleration of tangent acceleration.
But the answer is 0.2.
The answer is not 0.2. The answer should be A, 0.25, because you have this component.
But what do they have? The answer is
The
E?
answer is A. Is A. It's 0.25.
But explain what you're doing here. So we just take the alpha times r and that's it? 2
No,
times 0.1?
We also need to calculate this acceleration. So
And that's how you get 0.25?
yeah. And this one you got, because the velocity you can calculate. Or you can do is equal to times R2. So this, if you calculate, you can get 0.144 meter per second squared. So you have two acceleration. For example, remember before when we do this kind of questions, when this ball is like going a circular movement, there's acceleration, right?
Right. I mean, I'm
So-
understanding it. I'm just trying to put it together. So we
Yeah.
take 0.2 square plus 0.144 square, and that gives us this?
Yeah, it's 0.25. So you need to consider
Because they're in
this-
components.
Yeah. So
Okay.
that's two different directions. One is tangent to the circle, the other is toward to the center. And then you need to consider both of them to be able to get it. Let's try if I can answer number 5. Number 5. this object is 0.5 kilogram. And
I know, let me just say how he said to do it. With this, you're dealing with two different forces. It would be the force, the torque, because you're dealing with rotation,
yeah,
and one is going down and one is just rotating.
yeah,
So that would be sigma F equals MA, and for the pulley, because it's just rotating, it would be sigma torque equals I alpha. That would be the two equations you would do for this problem.
I alpha.
Is equals to the sigma torque, and a torque would be the tension.
The tension will be I
The
times
force.
R distance.
And the I for,
The moment of
I think that was
inertia.
1/2.
Okay. So yeah, we can try to figure it out. This one, first we can analyze this object. There is gravity, and then the tension, right?
Minus the tension equals to MA.
Yeah, exactly. Minus tension is equal to ma, which is the acceleration is 5 meters per second, right? And then you will be able to calculate the tension, because you know here and you know here. The tension is 2.4 Newton if you calculate. So we know the force here is 2.4 Newton. And this force is equal to this. That's what I think. Oh, the acceleration time.
The alpha times, but in order to change that, it has to be A over R, because you'll have like 3 unknowns or something like that instead of 2, because the conversion between alpha and acceleration is A over R.
Because we know that here, right now, the acceleration is 5 meters per second square. And we know the radius is 0.2 meters.
So you have to convert alpha into
To the radius acceleration, right? And this should be, the way I convert is how many circles per second square will be 2 pi r. Pi r circle times 2 pi. So it's A over R, right? A over R. Alpha. So that will be 5 over 0.2. Right? Calculate is 25. It's 25 per second square. So the tension, I don't know this equation, so you're sure about this equation, right? Is times the R, and that should be T over R. You know T is 2.4. And then the acceleration is 25.